Okay, let's have a class, and we will continue to talk about the applied microbiology. And today I will give you an introduction of food and microbial safety. And Thursday, Dr. Kenny will give the specific talk about cleaning, sanitation, and also the hazard. So let's see what the overview of the foodborne illness in the United States. And you can clearly see that. The foodborne illness in the United States, which is surveillance done by the CDC. So what is CDC? This name is actually confusing you. This is called Centers for Disease Control. Lots of you will be down here. No, it's for Centers for Disease Control and Prevention. Don't forget about control and prevention. You heard about CDC millions of times in the last couple of years because they gave the guidance for the coronavirus. They also do the surveillance of the foodborne illness in the United States. The first one is done by 1999, which is almost 25 years ago. By the time there is a 75 million illness per year in the United States, hospitalizations 323,000, which means how many people are in the hospital because of foodborne illness. How many deaths? Annually 5,200, cost 8.4 billion. The second survey is the newest one what we get. The survey is done by 2010, but they published the results in 2011. What do you find? Illness per year in the United States is dramatically decreased. It's only 48 million. Hospitalization decreased more than half, end up with 128,000. This is also decreased about 2,200. However, what is increased? The cost. Obviously, because the medical cost is increased dramatically by those days. Okay. Now, why there is a decrease? We will mention because there is an E. coli 057H7 horrible outbreak happened in 1992. Then, United States Department of Agriculture start to require the meat and poultry processor need to have a hazard plan, and combined with other type of the state or federal regulations, so dramatically helps to control the foodborne illness. So we give credits to all the federal agencies, university research faculties, extension agents, and also the state policy makers. Everybody worked really hard, so you see the number is dramatically changed. This suppose has a number come out. Somehow 2030-ish. Every 20 years they will do that. Okay, so this is the latest number we can get. What are the important foodborne pathogens we care about? Well, basically, all the microorganisms, and as long as it's harmful, we all should be careful. But what's the target of the foodborne pathogen in the United States? Basically is in the middle listed 5, which is Campylobacter, Salmonella. They are highly related to chicken meats. We will talk about. E. coli 057H7 and non-057 STEC, which means Shigella toxin producing E. coli, acronym STEC. Listeria monocytogenes Clostridium botulinum. Others we listed here, like norovirus. There happened outbreaks in Yellowstone National Park back in 2013. Everybody go there, they have vomiting, diarrhea, nausea afterwards, but that doesn't cause any people dead. Shigella, same has a Shigella toxin, but this guy basically is for the daycare kids. So that's a risk group. Toxoplasma gondii, it's a parasite in the cats. So basically they will tell you, the pregnant woman, you should not have a cat because Toxoplasma gondii could cause miscarriage or steal baby. Obviously, we always will say there's an emergent microorganisms. We never know. So since the COVID-19, there is some of the predictions they say something like that could happen every 15 years. It sounds horrible, but we have to recognize they always have emergent organisms. Let's look at a couple of the tables, okay? This table tells you the top 5 pathogens cause domestically acquired foodborne illness in the United States. The number 1 is norovirus, followed by Salmonella, the Clostridium perfringens, Campylobacter, and the Staphylococcus aureus. But very ironically, Staphylococcus aureus, you don't have to report to the CDC, so I don't know how that data comes from, but it's just tell you the top 5. Number 1 is norovirus. The top 5 pathogens cause domestic acquired foodborne illness resulting hospitalization, which means you have to go hospital. Number 1, Salmonella non-typhi. Okay, by the way, Salmonella, I mentioned about that earlier. Salmonella typhi is a different story. Let's talk about typhi marron. Mary marron, that's a different story. What we talk about here is non-typhi. Second, the norovirus. Next, the Campylobacter, Toxoplasma gondii, and E. coli 0157H7. That's what causes the top 5 hospitalization. This is the key. We always care about which pathogen is the number 1. Will cause death after foodborne illness. This is touch people's nerve. Is that right? You have a diarrhea, you go to the restroom a couple of times, you solve the problem, it's okay. But the death, nobody can save back. Number 1, Salmonella. Number 2, Toxoplasma gondii, Listeria monocytogenes, norovirus, and the Campylobacter. These are the top 5. Salmonella is the number 1. Very interesting. Although E. coli 0157H7, the outbreaks we will mention later, which has led the United States have a new hazard plan comes out in 1990s, it's not even the top 5 list. So very interesting. Okay, what are the major foodborne pathogen concerns? So before I talk about these, be very curiosity, or just give you a warning that every product could be contaminated with all kinds of pathogen. But the data here is coming from major recalls and outbreaks in the last 20 years. Fresh meat, what do we care about? Salmonella, Campylobacter, if it's chicken meat. If it's red meat, beef, pork, even lamb, E. coli 0157H7 and non-0157 Shigella toxin E. coli. We'll talk about the detail. Ready-to-eat meat. Let's say you have a ham, you have a turkey breast, you have a hot dog. Number 1, Listeria monocytogenes. There is a major outbreaks happened in 2000 to 2002. Cost $4 million lost in the industry. Fruits and vegetables, this is relatively new. In the recent 20 years, long time ago, we always think fruits and vegetables are safe. And especially we eat directly from the raw status, like we eat salads. We put on the salad dressing, we eat it. However, there is recent more and more outbreaks for fruits and vegetables. Number 1 pathogen is Salmonella, followed by E. coli 0157H7 and norovirus. The targets could be Salmonella, could be tomato. E. coli 0157H7, lettuce or other leafy green. Well, norovirus, typically anything could happen. So let's talk about something. Listeria monocytogenes. So we want to talk about the listeria. What the listeria looks like. This is gram-positive single arrangement and large lots. There is 6 subspecies. 6 species name. Listeria monocytogenes is the number 1 cause foodborne disease we care about. Listeria inocia, this is, we call it a surrogate. The pathogen surrogate. So in some scenario, let's say we are doing the research in food processing plants or some of the pilot plants, we cannot use the pathogen to do the validation study. We have to using a surrogate. In other words, the biosafety level is decreased a little bit. Listeria monocytogenes is biosafety level 1, and the Listeria inocia is biosafety level 2. Okay, all the others, Listeria cinegeri, inonovi, Vishhenry, and greeny, those we barely heard about. But where original Listeria comes from soil. And this is a very typical symptoms for Listeria monocytogenes on blood agar. This is, we call a beta hemolytic. See the transparent zone surrounding the gastric area? Okay, Listeria monocytogenes we just mentioned. Gram-positive, it is a Petrotrichus flagella. So do you remember the flagella, the morphology? Monotrichus, Amphitrichus, Lithotrichus, and the Petrotrichus. If you see Petrotrichus, which means flagella has been covered the whole surface, they have a very strong moving ability. That's a real movement. It's a facultative anaerobes. Do you remember? We have aerobic bacteria, let's say Pseudomonas, and we have anaerobic bacteria, let's say Clostridium. They do not like oxygen. Oxygen is a toxic. Why? Because they do not have SOD, nor catalase, is that right? SOD, super oxide dismutase, catalase can hydrolyze H2O2, become water and oxygen, and this guy usually is become, so super oxygen become triplets and singlets of the oxygen, okay? Right in the middle, we call it a facultative. What this means? They grow without oxygen, but better with oxygen. This is also the tough one. This is the reason why Listeria monocytogenes will grow in the vacuum package bag. So even vacuum package, you know they pumped out all of the oxygen, they still survive because it's a facultative pathogen. Hemolysin positive, Listeria lysine, cause beta hemolytic. That's what happened. Okay, what we care about? There is a different serotyping. There are 13 serotypes. 95 of the Listeria foodborne listeriosis is caused by serotype 0.5A, 0.5B, and 4B. Typically in the North America, serotype 4B accounts for 65 to 80% of the Listeria monocytogenes strains. This is people do the serotyping. Okay, this slide, which tells you very important why Listeria monocytogenes is a big risk. Because if you look at these characteristics for the growth, they basically could be survived and colonization and multiplication in everywhere. Their growth temperature at 37 degrees Celsius, which means this is a mesophile. Okay, when you look at here, they grow 37 degrees Celsius, which means this is a mesophile. Remember mesophile, 45 degrees Celsius. They need a vitamin and amino acids to grow. Oh, a little bit fastidious, but not really. They can grow 10% salt. This is a big problem for those for the industry. Do you like hot dogs? You don't like it, some people, because it's salty. It's called unhealthy foods because it's high salt and high fat lipids components. It could be up to 5 to 10% of salt, but Listeria monocytogenes can survive. What is called? Halophiles, is that right? That's terminology for that. The pH growth is very wide range, 4.1 to 9.6. It's across acid and to small alkaline conditions. This is a key. Can grow down to a maximum of 0.5 degrees Celsius. I actually made a mistake at the beginning. What this means? This means Listeria is cyclotrophs. They can grow at a refrigerated temperature. That's a risk. Most of the foodborne pathogens, E. coli, Salmonella, they will not grow in the refrigerator. Listeria monocytogenes will grow and grow really well. So basically what we did modeling before, 2 cells, they could grow to 10 to the power of 8 or 9 logs after about a month. So that's grown dramatically. Another thing we also need to know, Listeria monocytogenes can grow at lower water activity. Do you still remember what is water activity? The partial vapor pressure above the food products divided by partial vapor pressure of a pure water. So water activity's range is 0 to 1.00. Now what is the water activity range of this guy? This here basically is some of the fermented foods. Fermented meat like salami, like some sausage. These are the ones with a little bit lower water activity, but the Listeria monocytogenes can still grow very well. Okay, this is a big deal. Why today we talk about the Listeria monocytogenes? Because it has a multi-state outbreaks back in 2000 to 2002. You can see these. In 1998 to 1999, 24 states, 180 cases, 18 deaths. Listeria monocytogenes will cause stillbirth and miscarriage. So pregnant women should not eat daily meats. That's a common sense. If you want to eat, make sure you microwave. Daily poultry meats in 2000 caused 29 cases, 7 deaths, 3 miscarriages, and 10 states. Daily poultry products in 2002, 46 cases, 10 deaths in 8 states. That's a big deal. How many people died you can add up together? 35 in just like 3 years. And cost about $4 to $5 million lost in the industry. Therefore, what we should do, USDA FSIS. What is USDA? United States Department of Agriculture, you know. This is Department of Agriculture. What is FSIS? Right here, for the safety inspection service. They come out in 2003, just right after the outbreaks, with 3 alternatives. Which means, number one, you need to do post-salinity treatments, which means after cooking, with antimicrobials. FSIS has a big list of all the approved antimicrobials to be used on the food surfaces, on the ready-to-eat meat surfaces, and their concentrations and their combinations. If you only want to do post-salinity treatments, that's okay, like UV lights, or you want to do one of them, either antimicrobials or one way or the other, that's okay. They also give you an option. If I don't want to do anything, I need to do a good job of sanitizing. This is related to the sanitation standard operation procedures and the good manufacturing practices, but we have to do a very frequent of microbiology testing. And for the microbiology area, the microbial testing is a big deal. We always remember microbial safety cannot rely on testing. This is different from what you did for COVID-19. Everybody go there to test it. No. Because the food is a matrix. It's a different morphology. And you produce 1,000, 10,000 drumsticks. You cannot to do the testing for everything. You can't do testing for every drumsticks. And the testing takes a longer time. So, the testing usually have a plan, which is class 2, class 3 plans, which is based on statistics model to determine whether the plant is going to be rejected or can keep going. So, microbial testing is always a very tricky thing in here. That's why all the time we use enrichment, we strict plating onto the selected media, we see the colony growth and do the confirmation, and then later on people can do using PCR methods, or right now they're using nanotechnology or different rapid testing methods. But I just want to tell you, if you don't want to do anything, the microbial testing will be tedious, and time consuming, and it's expensive. Okay, but anyway, that is one of the 3 alternatives. Now, what is the overview of the annually in the United States for Listeria monocytogenes? And you can see on the slides, they cause approximately 1,600 foodborne illness, 1,500 hospitalization, and 260 deaths. This data is even 10, 15 years older, but right now we don't see the new data. It could be even worse. The next one is E. coli 0157H7. Okay, we mentioned about E. coli lots of the times. E. coli is gram-negative, lots. But there's lots of E. coli we mentioned about. These are different E. coli. Okay, we had ETEC, enterotoxigenic E. coli. EPEC, enteropathogenic E. coli, EIEC, enteroinvasive E. coli, and EHEC, enterohemorrhagic E. coli. We care about this guy. This is what E. coli 0157H7 belonging to. Okay, very important. So let's talk about the story of 0157H7. The first time 0157H7 recognized in the United States is 1982. I was born in 1981, so I'm 43, 44 years old. That's 42 years ago. In Oregon and Michigan, in the cattle plants. Nobody cares by the time. So what's the 0157H7 will causing? They will causing a very dramatic stuff called HUS, hemolytic uremic syndrome. what happened is bloody diarrhea, bloody water diarrhea with degradation of the kidney function. And could it be related to neurological symptoms later if they develop? They will cause people to die. And I want to tell you one thing, E. coli 0157H7, it's really a risk. Do you know how many cells it could cause the people to die? 10 cells, as little as. That means 1 log. CFU per ml. Very small, a couple of cells could cause people to die. Now why? Why this pathogen cause hemorrhagic uremic syndrome? The reasons it will cause Shigella toxin. The Shigella toxin, we have Shigella toxin 1 and also Shigella toxin 2. Acronym STX1 and STX2. These two toxins will have a target site on the kidney. They could be attached to it and recognized. It's called GB3. Glycolipids, global triacyl ceramides. That can be attached with these toxins and cause a problem. And don't forget, this toxin is also an AB toxin. So we talk about the toxin will cause a problem. But in other words, this also tells you something. One of the rapid testing methods for 0157H7 is to testing toxin. So what we can do? If I have a beef products, okay, I had a beef. I put in a solution with tropic soil gloss. And I'm going to do enrichment, 35 degrees Celsius, 24 hours. And I'm going to run the PCR, polymerase chain reaction. If I see my signal of Shigella toxin is enlarged or multiple copied, which means there is Shigella toxin on this beef, then most likely there is 0157H7 there. Or could it be not 0157 Shigella toxin, generally E. coli. So this tells you Shigella toxin could attach to GB3 of the kidney, will cause hemorrhagic uremic syndrome. It's an AB toxin, and by the same time, which tells you the rapid testing, you can use it to test in the presence of toxin. This is what the industry they do. And this beef enrichments, they actually sometimes enrich at 42 degrees Celsius by only 9 hours. Then go to run the PCR. Because PCR is a multiplication of the DNA sequencing. It's a DNA copy of the DNA. Then the signal could be enlarged and you could be recognized. Now we mentioned about 1982. It's first recognized in Oregon and Michigan. Nobody cares. This is a big deal. In 1993, Jack in Box in Seattle. I worked at Seattle for a year in 2010. I worked in a private microbiology testing company before I go to academic area, become a faculty in the university. In 1993, Jack in Box in Seattle. The problem is the hamburger. The undercooked hamburger eaten by lots of people. After that, they had vomiting, diarrhea, nausea, all kinds of things happens. 171 hospitalized. 45 children, which is hospitalized. What's a bad thing? 4 kids are dead. So you look at the news of food safety. Long time in the United States, they will say hamburger killing kids. Let's talk about that. By the time my old boss, Dr. Mansell Samantha Paul, is in a faculty at the University of Washington Microbiology Department, Because of this outbreaks, there is a market for that to do the rapid testing of Shigella toxin E. coli. So he, coming from that university, it's a big good university. They have a company called IEH Consulting Group, and I worked there for like a year. There's a group because the company becomes larger and larger. It's a major contribution of the food safety in the world right now. Okay, that's my first job. Just want to let you know. And because of this outbreak, has 4 kids died. This touched the nerve of the White House by the time the President Bill Clinton and Vice President Al Gore want the Congress to do something for food safety. This comes out with 1996 of the HACCP plan. But this could be easily done. What they do? Roughly cooking. Is that right? If you don't eat undercooked hamburger, you're going to solve the problem. This is later on, the FSIS have a guideline. The cooking could destroy E. coli 157H7. If you cook to the internal temperature to 160 degrees Fahrenheit, you can roughly kill E. coli 157H7. Okay, there is 2 things we want to mention. One is the internal temperature. This is a steak. What's the temperature they'll talk about? Is geometric center. It is not the surface. This is a very important misconception people need to know. Because when you say cook to 170 degrees Fahrenheit, 71.1, lots of people say, oh, I already did it, it turns brownish color. It's a geometric center. So what you should do? You need to put a thermocouple or sensor to monitor the temperature. In the lab, we have a thermocouple could be testing every 5 seconds. Their industry, the beef industry, usually they do is using a metal or manual thermocouple to test the internal temperature. Now, not only that, after you cooking, when you order beef steaks, you're not going to eat immediately. They will be rest. 3 minutes, then give it to you. What do you mean the rest? Because when they cool down, they take out of the grill, the surface temperature going to be decreased dramatically, but the center temperature is still high. So during the rest time, they still call killing bacteria. And that is important for the rest time. Now, we go back to talk. Then you have a question for me. Then you say, you just well done cooked. But why there's a problem? Because for the beef, we do not only talk about the safety, we talk about the quality. And we talk about palatability. What we talk about? What do you care? Juiciness, flavor, and tenderness. And the survey has been showing more than 50% of the people, they care much more about the tenderness, the juiciness, and the flavor. If you overcook it, what are you going to do? It's going to become tough, is that right? You cannot bite it, it's not tender anymore. That's the issue. Okay, so how to improve the tenderness? There's a lots of ways we could do. Add the chemicals there. You break down active myosin cross bridge, and you do a needle and the mechanical disruption of the muscle tissue. It's a big topic, talk about tenderness. But at the same time, we have to be careful about the safety. Okay, so there's a lots of topics. This simple picture does not solve all the problems because 50% of the people will like a tenderness. So when you go to a restaurant, you order beef steaks. Lots of the time you order a rare or medium rare. Even though it's still bleeding, you eat it because you like the tenderness. You don't like the well done one, the very well done. Why? Because it's too tough. You cannot even bite it. And also there's a moisture is gone, and there's not much juiciness. Now, juiciness is actually not really related to the temperature. It's amount of the fat. Is that right? So the beef, you have an intramuscular fat. That's why we have another skull. We call it a marbling skull. Okay, so you have choice primer for those marbling skull. That's another topic. So this happens. We said by the time the president, the Congress has to do something. So where they go? They look at all the records. They propose a hazard plan. So what is hazard? Hazard analysis and critical control points. That is what HACCP means. Where it comes from? Originally it comes from NASA, which is Pillsbury Company, in 1950. By the time the United States is doing lots of the work in the space, for the astronauts, you have to make sure it's 100% for the safety. If there is something happens in the spaceship, what are you going to do? There's no way to do. Is that right? So by the time the Pillsbury Company made sure the hazard plan. But always remember, hazard is a proactive intervention. I would say that. But always remember, hazard does not equal food safety. It's a proactive intervention way to do. Does not mean any food products you have a hazard plan, it's 100% safe. This is lots of the time we'll misconception for the consumers. So make sure you understand about that. Okay, what is the hazard we care about? We're going to do hazard analysis first. This will be a systematic for all the ingredients to manufacturing process, food products, handling, packaging, storage, distribution, and end consumer use. So said very simple. Hazard analysis has to do from farm to table. That is important. So what is hazard? This is a hazard plan. Hazard has 7 principles. This is published for Code of Federal Register, CFD, CFR, in 1996. The full name of this document called Pathogen Reduction, Hazard Analysis and Critical Control Point System Final Rule. This is about 350 pages, and I read it from the first one to the end when I was a PhD student. But I want to tell you something very ironic. In this document, what's the pathogen reduction talks about? Surprisingly, it is not O157H7, not even E. coli. What's that? Salmonella. Very surprised. And then they mentioned about surrogate bacteria, which is biotype 1 E. coli. Biotype 1, BIO. Biotype 1 E. coli. Very surprised. Okay? What's the principles of HACCP? HACCP has 7 major principles. Number 1, conduct a hazard analysis. What are the hazard analysis we'll talk about? Biological, chemical, and physical. When we talk about the bacteria, it's biological hazards. Establish a critical control points. There is a long way, a flow chart of we talk about food processing. There are different stages. We need to determine which stage is more important to control this passage. So let's say we are doing the cooking. Okay, cooking is a major step. That's a critical control point. The target hazard is E. coli 0157H7. Establish critical control points. Number 3, establish a critical limits corresponding to critical control points. What is critical limits? It's a physical or chemical parameter to make sure the pathogen is under control. We could reduce it, we could eliminate it or reduce it to acceptable level. So what is the critical limits for cooking? 160 degrees Fahrenheit, 71.1 degrees Celsius. Always remember, at the hazard plan, the critical control points corresponding to critical limits is a fixed number. It cannot be a range. But in the FISMA regulation, a new one, that could be a range. Okay, but don't confusing about that. Number 4, conduct a monitoring procedure. What means conduct a monitoring procedure? When you're cooking, you cook to internal temperature 71 degrees, 71.1 degrees Celsius. We need to make sure you are doing that correctly. That's a monitoring procedure, which is a quality assurance person could do it. Make sure you did it. So monitoring procedure sometimes is also very tricky. So for example, we all know that when you are making hot dog, you should add sodium chloride or sodium nitrite. That's called curing ingredients. Otherwise, your hot dog not looks like purple color. And the sodium nitrite, the concentration has to be less than 50 ppm. How do you do a monitoring? You could not add it, then you take it out and say, I'm going to do the chemical testing. What's a monitoring? Then the double vision and the double inspection. So two persons there, they make sure the other person did it correct. That is the way to do the monitoring. Okay? Lots of the time, what happened? There is a monitoring C, but you have a deviation happens. Conduct corrective actions. If deviation happens, okay, one day you see food processing is cooking sticks, and you're monitoring. You find that the internal temperature is not reach 150 degrees Fahrenheit. You find it's only 155 degrees Fahrenheit. They are off the shelf, or they are off the grill and packaged already. What you should do, that's a deviation. They certainly cannot go to the markets. Because when they go to the markets, it will cause outbreaks, or at least it's a recall. And if the products is already go to the markets, you have to recall. Now there's a different level of the recall. Okay, class 1, class 2, class 3. Class 1 recall, which means pathogen. Class 2 recall usually is an allergy. And class 3 is a mislabeling. That's another topic. So corrective actions, you have to do it. Then what you're going to do? You're going to destroy it? You're going to recook it? It all depends. Most of the time what they do. And I tell you one thing, if it's ground beef. Okay, if it's ground beef, the critical control points is only 4 degrees Celsius storage. You make sure to control the 4 degrees Celsius. If one day the refrigerator or the cooler is broken, it's an abusive temperature, what you do? You could cook to ready to eat meat. for ground beef. Now for these beef sticks, it's undercooked. You could be recook it. But recook it, certainly most of the time you cannot become a sticks because tenderness will be changed. So what you do? Obviously not throw them away. You become a pet foods. That's another way we can do. Okay, so lots of times they become pet foods. And I want to tell you the truth. In the United States, there is an anonymous survey has been done. More than 70% of the hot dog is coming from the ground beef, is not passing the internal monitoring procedure. They think there's a risk there, so they cooked to make a hot dog. And there's lots of the pet foods, they even do it from the human foods. It's failed the HACCP system, so they go to become a pet foods. That's the way allowed to do it. Okay? Okay, we did all these things. We need to make sure that the critical control points, the critical limits is well established. So what we have to do? Validation study. This validation study we have to do is internal. The internal R&D person or in the internal quality assurance person could make sure the critical control points is under control and the critical limits is works. And we also need a third party to do the verification. Make sure the whole system works. Okay, do the verification. Last one, record keeping and documentation. And don't forget, every single piece you have to document it. So when the third party comes there to do the verification, the first thing is that look at your recording. Let's say you're cooking, you need to have a cooking sheet. The temperature log and the storage temperature log. Every single column you need to have people is monitoring, have a signature there, and have a supervisor signature there. If the deviation happens, you need to go back to see how the deviation happens. Did you solve it? And if the product has been out of the markets, how you do it, they all have to do a good document. That's called the record keeping and documentation. And I hope Dr. Kenny will mention about this more details than me on Thursday. But like I said, even if you do all these HACCP plans, you will follow these HACCP principles. Is that means food safety? No. This is what happened. HACCP started to require the poultry meat processor, we call it the establishments in the United States. And after 1997, they started to enact it. The small or very small establishments, they allow you to have 3-year delay to establish it. But later on, they want everybody to do. That is why the extension specialists at Pennsylvania State University, they are very busy. Because lots of the small producers will ask them, consult them to talk about the HACCP plan. But does that mean food safety? Obviously not. You go ahead to see. In 2002, there is a beef trimming ground beef, 9 million kilograms recalls. In 2007, there is a mechanically tenderized, chemical injected beef, 116 kilograms is recalled. And not only that, we expanded our 057H7 go to other species. By the way, what is O means? Do you still remember 057H7? What is H? That's flagella. What is O? Sugar. Is that right? The side chain of a polysaccharides. It's a sugar. Then to a serological typing, 01578H7, like give them an ID. Like you have a WVU 800 student ID, the same thing for passenger. And they find that not only 01578H7, there is an additional 6 strains they could generate shake toxin. they also have the similar results or similar risks to 0157H7. What are they? The 026, 0111, 0103, 0121, 045, and 0145. So, after 2012, the FSIS they require not only 0157H7 and all the other 6 Shiga toxin producing E. coli also need to be tested. And these 6, we call it big 6. They all belong to enterohemorrhagic E. coli. Okay? Same thing will cause hemolytic uremic syndrome. So that's something we talk about is meat safety. Like I said, fresh produce is always safe. You buy a bag of salads, dipping the dressing, there will be a lunch or dinner. We always think it's safe until this happens. In 2006, in Salinas, California, okay, you need to know a little bit about California. We are here. California right here. SFO, is that right? San Francisco, San Jose, just right like this. Los Angeles, LA right here. San Diego. Okay. This is a big city. This here is UC Davis, which is Sacramento. Okay. This is Central Valley. There's 3 major companies in the United States for us, the salads. Dow, Fresh Express, and Taylor Farm. 95% of the fresh produce coming from there. Where the other places? Yuma, Arizona. Tomato comes Florida. Central Valley. This is Miami, Palm Beach, for the Lauderdale. That's Broward County, Palm Beach County, Miami County. Right, Central Valley. That's Orlando. Is that right? That's Daytona Beach. That's Pensacola somewhere. Okay. Arizona, California, Florida is a big 3 fresh produce states in the United States. That's the reason University of California, Davis, University of Florida, and the University of Arizona at Tucson, those 3 places have a very good program of plant science and even food microbiology. Focus on fresh produce safety because of the market there. This is what happened in Salinas. Salinas right here. What happened? A packaged spinach find E. coli 0157H7. And people are dead, 3 deaths. 199 persons, 26 states, 51% hospitalized, 71 female, 11% children, under 5-year-olds, 3 deaths. There is 1 case in West Virginia. Not a big deal. So, what are we going to do? By the time there's no regulation, people start to do the research for that. I remember in 2008, when I was a student, Dr. Michael Doyle from University of Georgia, Athens, his group did some of the fresh produce study for E. coli 0157H7 control, and the posters is being surrounded by hundreds of people. You cannot even see it. And his symposium talk about pathogen controlling fresh produce is filled up with everybody. You cannot even get to the door. Because that's the first time we do research about fresh produce safety. People still don't pay much attention until this thing happens. This is relatively a little bit new, but not older. In Colorado, in 2011, the Jason Farms, the cantaloupe has an outbreak with Listeria monocytogenes. There is 2 things will tell you. Listeria monocytogenes originally is only for daily meats. Is that right? Ready to eat meat. This time happens on the cantaloupe. This is an emergent pathogen. That's a category. An under-researched emergent pathogen. Second, it's very ironic that Jason Farms, before the outbreaks, there is a third party validation. They do give them a score. And they give them more than 95%. It's like an excellent pass, A+. 1 week later, the outbreaks happens. And you should know that cantaloupe is very tricky. What's the difference between cantaloupe and apple? Apple surface is smooth. Is that right? Has a major component is wax. What are the wax? CH3, CH2, 24, CH2, 29, CH3. A long chain fatty acids with alcohol. They could do is dehydration, so the bacteria will not grow. What are the cantaloupe surface looks like that? There are so many these niche area there. Bacteria could be there. Will generate a biofilm. Is that correct? If the biofilm generates, it will be 100 times, 10,000 times resistant to antimicrobials. So if you do not using antimicrobials, certainly people don't do. If you failed to do the sanitation, obviously the pathogen will grow, and when you process it, you cut it, it will be penetrated or transferred from surface to the inside. So cantaloupe by the time is a big topic. And this is really a big one. Because eventually touch 28 states, 33 people dead. Now by the time they actually are working, okay, which is trigger, another law comes out, is FSMA, Food Safety Modernization Act. This is signed by President Obama in 2011 into the law. So right now, if you go food safety training, lots of you want to get a certification. You could get a HACCP certification, but no longer that is a popular one. The popular one is FSMA, is Food Safety Modernization Act. Food Safety Modernization Act have 7 principles, 7 rules. We're not going to care about all of that. From our standpoint, for myself, as a food microbiologist, we care about the 2. Produce safety, preventive control. This preventive control, I would love to tell you, it's exactly copies the HACCP principle. The only difference is they add allergy as a risk. What is allergy? Peanuts, not so allergy. We'll call it allergic. Fish is an allergy, egg is an allergy. And there are long lists for that. So, by the time people say there is a little bit of fraudulence happens, but the political area in the United States, for the food safety, there is FDA and FSIS. This document comes out which indicates FDA will take care of everything. Okay, now we're not going to go details of all these documents, okay, what they talk about, just give an introduction. FSMA gives lots of people a challenge. You need to have a new regulation. But they give flexible for small farmers, especially in West Virginia. If you 3-year average, let's say 500,000, you waived. If you distribute interstate with 275 miles, let's say you have a farm at Charleston and you're selling at Morgantown, you're good. And also your major distribution end user is directed to customers, restaurants, and the retail foods. But what do those people have to do? Obviously, you need to do something. Is that right? You cannot say I'm not doing anything. What they have to do? They need to follow the GAP. Good agriculture practices. This is not a commercial brand for the coat, okay? Good agriculture practices is a comprehensive system for reducing foodborne illnesses spread primarily by microbials. It is also make sure the quality assurance. Basically, you can see the before planting, during production, during harvesting, post-harvesting, cover the farm to table, the whole system. FDA has a document published in 1998 talk about the guidelines to minimize microbial safety in fresh fruits and vegetables, which is covers every single piece of the GAP. Like I said, we're not going to read it, but what the GAP tells us. 4 major items we need to know. Safe soil. What are we talking about safe soil? Manure, compost, pathogen control. You cannot use fresh manure. Sanitary rule. You cannot use fresh poop sample from the cattle and spread. Because what are the bacteria there? Coliform and the fecal coliform. Remember, our drinking water is zero tolerance for coliform. Clean water, no coliform and fecal coliform. Clean surfaces, what that means? No biofilms. You need to do a good job of sanitizing and cleaning. What means clean hands? Using antimicrobial soap to wash at least 30 seconds, 25 to 30 seconds. How you make sure doing that? You're not going to count Mississippi for 30 seconds? No. People say you can sing a happy birthday song. That will be counted for 25, 30 seconds when you wash your hands. So this is the basic things of 4 major items in a GAP. Okay? I think the time is there, so we will left 1 slide. We'll talk when we're back. This is the important slides we want to talk about, the surveillance and the regulation. Okay?